to listen to us. Okay, so law of sines and cosines, basically, and like I said, if you've done Foundations 20, you've done this already. So these are specifically, you'll use the law of sines and the law of cosines when you are not working with a 90-degree right triangle. Couple things to take note when we are working to find a missing side or a missing angle is just our labeling of those triangles. So we have a few things that are happening. We have our vertices, which are our angles. Those are these up here. This is considered a vertices. So wherever our triangles create that point, okay, and change direction, they are always considered, our angles are always considered the capital letters, okay? And then the sides are always lowercase. And those sides, the names are named for the letter of the angle that is across from it. So if this is angle A up here, capital A, the side opposite to it is down here, and it's just denoted with a little a. This is angle C, and it's notated with a little c, and we've got a little b. Another thing, an oblique triangle is a triangle that does not contain a right angle triangle. We're talking about always about ones that aren't right triangles. So basically what we will end up doing, a couple things that we can recall from that, I guess, is if we look at SOHCAHTOA, so if you're thinking of the S being sine and the C being cosine and the T being tangent, we kind of work through that whole piece. We can actually use the SOHCAHTOA to find other unknown angles in a triangle. We can go through some of those pieces. If we have it in the form of a right triangle, we'd find those unknown pieces using SOHCAHTOA. Well, what we're doing, we're going to do cosine law. If it's an oblique, if it's not a right triangle, then we have to either use the cosine law or the sine law. So what you'll notice in here is you're going to have letters that represent the sides of your triangle. And also, you'll also get an angle in the cosine law. And that angle measure, this is cosine of A, this angle measure, corresponds to whatever side is out here isolated. So these ones will always correspond to one another, okay? Small b, side B, corresponds with angle B. So you know if you're trying to find angle B, you know your side that corresponds with angle B will be over on the other side of your equal sign. Then the other two angle or side measures are going to be squared and added together, and then you're going to subtract them and have 2 times those same 2 side measures are going to get multiplied together with the cos of the angle B. Now, these are A, B, and C. It doesn't matter how your angles are measured. You just have to be, or how they're labeled. You just have to make sure that their corresponding sides match up, right? So this could have been M, N, O, which means this would be N, this would be a little m, and this would be an O. Literally does not matter the label that you have on it, okay? So basically, the main thing is if you're trying to find this particular angle measure, which is angle C here, you would have the corresponding side measure would be across the equal sign on the other side. Is there any questions with that so far? So like I said, this shouldn't be new if you're in Foundations 20 already or did that. So this is going to be kind of like a little bit of a recap for you. So let's kind of put some of this into practice then and look at a couple of these examples. So I've got this triangle ABC. I've got angle A being 58 degrees. I've got this side over here is 40 meters and this one is 32 meters. And it says find the length of CB to the nearest meter. So that's this piece down here is length CB. Now, if I want to do proper labeling on here based on my angles that I have, this over here is technically A. This opposite over here is a small c, and over here, this is a small b. So now, if I think about that, so when I look and use the cosine law, I can either find a missing side or I can find a missing angle, depending on what information I've already been given. So in this instance, it looks like I've got two sides and I've got an angle measure, but I'm missing a side measure. And now if you notice, if I think about my cosine law, my missing side measure that I'm looking for corresponds to the angle measure that I have, okay? Which is going to be really important for us moving forward, because that means I'm going to let the little a, that side measure, equal, because if I'm looking at my cosine law, I'm going to let it equal the square of the other side plus the square of the other side minus 2 times these two sides times the cos of my angle measure, cos of A. And again, this side measure has to correspond with the same angle measure. They are the ones that correspond together, so they have to go here. I'm not going to put a B over here because I don't have the cosine of B. Okay, I'm not going to put the C over here because I don't have the cosine of C over here. All right, so once you're at this stage, now you're just a matter of plugging in everything, all your values that you know. So in this case, B is 32, and you're going to square it. You know your C is 40, and you're going to square it. And you've got your 2 times 32 times 40 times the cos of A, which is 58 degrees. Okay, questions so far with that, and just in terms of setting up the formula and figuring out where everything goes? Okay, so since my a squared is the piece I'm missing, what we ultimately now have to do is we got to simplify this whole darn side. So we're going to get everything together, essentially get it down to one single number. So 32 squared gives me 1,024. 40 squared should give me 1,600. And I'm going to minus, I've got 2 times 32 times the 40, which is 2560. And the cos of 58. Now, you have to make sure on your calculator that you are in what we call degree mode, DEG. So make sure in your screen of your calculator that you're in DEG, because sometimes your calculator, you might be in radians, which is RAD. We don't want that, okay? You need to make sure you're in that, because if you're not, then your answer, you may do all the process perfectly, but your answer is going to be off. So in this case, the cos of 58 is going to come up with 0.5299. Go 4 decimal places just to keep that accuracy there. And now what you're going to do is you're going to multiply these two together. So you're going to have 2560 times 0.5299, which is going to give me 1356.54. And I've got 1,024 and the 1,600, which is going to give me, and then I'm going to subtract those two, and that's going to give me 1267.46, and that equals a squared. But I still want it to be just a, that side length. So you're going to end up square rooting both sides, and you are going to get a grand total of 35.6. Now it says determine the length of CB to the nearest meter. So that means this I'm going to round up to 36 meters. Okay, questions on that? All right, so this example is literally just like the one we did. So we're going to say, no, we just did that one. So let's just put I do want to go over this scenario though, because in this situation now, we're given all three sides and we're asked to find the angle measure. So this one, when we do this one, it is going to look just slightly different than what we're used to seeing, only for the fact of when you go to plug everything back into your cosine law, it's this piece that we won't know, right? We're going to know everything else. We're just not going to know that chunk of it. So when we go ahead and do this, if it helps, write out the cosine law. Really doesn't matter initially what your variables, whatever you're using, because what we can do based on what we've got going on here is we can change the labels according to what's been given in our equation. So in this case, I look at this and go, oh, I need to find this angle measure. Well, that angle measure right now is that capital F. So that means I'm going to not have cos of A, I'm going to have cos of F. So if I'm just going to rewrite this formula with the labeling that I have based on the triangle that I have. So now, because this is the angle F over here, then the little side F has to be over on the other side of the equal sign, right? These have to correspond. Now, E and D, D and E, it literally does not matter. They're your other two missing sides, so you're going to put them in, and then you're going to say 2 times the D times the E times that cos of F. So now that you kind of redid the labeling on it, now you can go ahead and plug in all your numbers, all your values that need to go in there. So in this case, F is 3.6. Now we're going to square that. D is 2.5, so we're going to put that in. And E is 2.6, and we're going to square that. And then we're going to say minus 2. And I'm going to have cos of F. So ultimately, in the end, what we're going to try and do here, what we're going to need to do is get this chunk, this cos of F, all by itself. In the meantime, we're still going to have to figure out some of these squared pieces. We're going to have to do some shuffling. Our whole goal is trying to move everything over to the left-hand side where, as much as we can, so that we can get the cos of F all by itself. So let's go through 3.6. We need to square it, and that's going to give me 12.96. 2.5 squared that is going to give me 6.25 plus 2.6 squared gives me 6.76. And now I'm going to go 2 times the 2.5 times the 2.6, which gives me 13 cos of F. So here's a common mistake that will happen is I think you recognize you can add these two numbers together, which is a good plan. So if we add those two together, 6.25 plus 6.76, that gives me 13.01 minus the 13 cos of F. Now, lots of kids will look at this and go, 13.01, subtract the 13. You can't subtract these two numbers because the cos of F is getting multiplied to this 13. So that's like saying, oh, I'm going to take 2 minus 2x. Well, we can't do that because these aren't the same terms. They're different terms. So we can't just go and subtract the two 2's together. Same thing here. So instead, if I'm trying to isolate this cos of F, I'm going to subtract the 13.01 from both sides, which I take the 12.96, subtract the 13.01, I'm going to get negative 0.05. And on the other side, I've got a negative 13 cos of F. Now, again, because this negative 13 is being multiplied to the cos of F, I can divide both sides by negative 13. So that means the negative 0.05 divided by 13, negative 13, is going to give me 0.0038. That equals the cos of F. Well, that certainly doesn't look like a degree yet. We're not, right? Like we're looking for this angle measure. Well, this isn't an angle measure yet, but we also don't have it down to just F, what angle F is. We have it as cos of F, which means if I divide this side by cos and I divide this side by cos, what I really have left then is I've got cos of -1, because that's what's in the bottom, times 0.0038. And that is what equals F. So back to your calculator, you have a button, your cos button right above it. There's a second function key. And if you use that cos of -1, so either your calculator, you're going to have to type in 0.0038 and then hit your second function cos. Some calculators, it'll be the exact opposite of that. But you're going to end up then actually getting what your degrees are. And in this case, F is going to come out to 89.77. So in this case, this could be degrees. This, if we round this to the nearest degree, we're getting angle F to equal, wait a minute, 90 degrees. That works out too. Okay. So that will not always work. That's just pure coincidence that it worked out to 90 degrees. So basically what you've got going on now is you've got the scenario where you could have a missing side that you're trying to find, or you've got a missing angle that you're going to find. So today we're strictly, that's all we're doing today, is just focused on cosine law. And then what we will do on Wednesday is we will focus in on sine law and kind of work through that process. This last example down here, again, same thing. It's the same scenario that we just went through. We have 3 sides and we've got a missing angle. So again, we'd be doing exactly the same thing. So I don't think there's a need to give you another example of the same thing. Do you guys have questions? Anybody have questions, concerns? Nobody's talking. Okay.